n dissimilar things, n dissimilar things taken small r at a time. Taken smaller at a time. In this we have three cases, and first one without repetition, and second one with repetition, and third one is at least one repetition. And first one is without repetition. Without repetition. Without repetition, the formula is NPR. And second one is with repetition. With repetition. You just remember these three formulas. With repetition, the formula is n power r, and this is 1 function. Already in 1 function you may study this one, n of b whole power n of a. With repetition, our formula is n power r and third one at least one repetition, and third one is at least one repetition. At least one repetition is equal to n power r minus npr. Total repetitions will come on with repetition case. Therefore, at least one repetition is equal to n power r minus npr. And these are basic concept and basic concept in the permutations. Okay, na? Right. The arrangement of n decimal things taken are at a time is when without repetition npr, with repetition n power r. At least one repetition n power r minus npr. While we are doing in probability questions, the favorable cases will come under these three formulas mostly. First one by using permutations with the function. Without repetition npr, with repetition n power r, at least one repetition n power r minus npr. Okay. You know how to solve this npr? npr, for example, I am taking 5p3. npr formula. npr is equal to n factorial by n minus r factorial. The value of 5p3, for example, 5p3 is equal to 5 factorial by 5 minus 3 factorial, and 5 minus 3 which is equal to 2 factorial. Observe here the value of 5 factorial, students. 5 factorial, that is 5 into 4 into 3 into 2 into 1. By denominator 5 minus 3, 2 into 1. And this 2 into 1 cancel automatically. 5 into 4 into 3. You directly write down 5p3 is there. Just multiply 3 consecutive numbers which begin with 3 consecutive natural numbers which begin with 5 in decreasing mode. That is 5 into 4 into 3. For example, 8p3 is there, or 8p4 is there. Write down multiplication of 3 consecutive and decreasing method. 8 into 7 into 6 into 5. Like that, we can solve NPR. N power r general formula. Number of 1 function, n of b whole power n of n. And at least one repetition, combination of this, that is n power r minus npr. Total permutations minus 1. That is equal. Okay, Nana? And next one here we have circular permutation. The number of arrangement of n decimal things taken are at a time. First one. And second case, circular permutation. Circular permutation formula. If we arrange the objects in a circle, around a circle, then that is said to be circular permutation. For example, like this. If we arrange the objects around a circle is said to be circular permutation. For example, here we taken n objects. In circular permutation, we should fix one. Okay. For example, in the circular permutation, we don't know what is first one and what is last one. You just fix first one. For example, in this n, you just fix one. Remaining, how many? For example, already n, one completed means remaining n minus 1. n minus 1. Therefore, the number of circular permutations are the number of circular permutations. The number of circular permutations are n minus 1 factorial. Remember this formula, the number of circular permutations of n minus 1 factorial. Where in garland and beads of chain, garland or beads of chain, pula danda, pusula danda. Okay. wherein garland are beads of chain. Beads of chain. In this condition, the number of circular permutations are n minus 1 factorial by 2. It appears only one direction, not double direction. Therefore, the number of circular permutations in garland and beads of chain or formula is n minus 1 factorial by 2. Okay, a circular permutation n minus 1 factorial, whether in garland or beads of chain, the number of circular permutations are n minus 1 factorial by 2. This is the basic concept of permutation. And later combination. Combination, the direct formula NCR. NCR is equal. NCR is equal. What is the difference between permutation and combination? Permutation means only arrangement. We just take all things and arrange in a row or arrange in a circular form, that is said to be permutation. Come to combination, we are just selecting the object. That is the difference between permutation and combination. Okay, in permutation, we are selecting and arranging. We are selecting and arranging. For example, the classroom. The classroom is said to be selecting the student and arranging in a row. That is said to be permutation. Come to combination, only selection. Come to combination, only selection. For example, on ground cricket selections are going on. That is said to be selection. The number of selections of n things taken at a time is equal, or formula in combination NCR, where NCR is equal to n factorial by n minus r factorial into r factor, standard condition. Okay, NCR is equal to n factorial by n minus r factorial into r factorial. Here, for example, I am taking one 8C3. The value of 8C3, 8 factorial by 8 minus 3 factorial into 3 factorial. Okay, write down this 8 factorial as 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 up to 1. But here in denominator we have 8 minus 3 factorial. 8 minus 3 is equal to 5 factorial. This one 5 factorial. Remaining 3 factorial, 3 into 2 into 1. This 5 factorial both are cancelled. Okay. And remaining 8 into 7 into 6 by denominator 3 into 2 into 1. The value of 8C3. Observe here, a 3 is there. Numerator 3 values, denominator 3 values. 8C3, 8 into 7 into 6 by 3 into 2 into 1, 3 to 6, cancel 8 minus 56. Like that you do the calculation. Okay. In NCR, I mean in combination also we have one formula. NCR plus NCR minus 1 is equal to n plus n minus 1 CR nana. A formula ఒక్కసారి చూడండి. First one, NCR is equal to n factorial by n minus r factorial into r factorial. And second one, NCR plus NCR minus 1 is equal to n plus 1 CR. And third one, NCR is equal to NCS. It's very, very important. NCR is equal to NCS. It implies either R is equal to S or n is equal to r plus s. Either r is equal to s or n is equal to r plus s. And finally, already you may did this in binomial theorem. NCR by NCR minus 1 is equal to n minus r plus 1 by r. N minus r plus 1 by r. Write down all this. And first one permutation and second one combination. Permutation means only arrangement. And most of the times while solving that probability on that numerator we have probability of anything, probability of P of A is equal to probable cases by total cases. In this we get that probable cases most of the times permutation. Sometimes rare condition we have like this also. Okay. And next one is probability. In this probability, the first one is random experiment. What is random experiment? Can anybody? What is random experiment? For example, I have a coin, and listen carefully. What is a random experiment? I have a coin. I'm spinning this coin, and what will happen, Nana? Definitely that will be head or that will be tail. Any one of these two. Either it may be head or tail. Everyone know the real, actual result. Everyone know that will be head or tail. But we know the actual result after the happening of the event. Okay. When coin in my hand, no one can know. After spinning of this one only, we can say that is head and that is tail. That is said to be random experiment. An experiment which the result is known, which the result is known without happening, before happening of the event. Okay. Right. 1 second. A repeatable experiment. This first one is random experiment. A repeatable experiment. A repeatable experiment. The result we know in advance. We know in advance. But actual result is known. We know in advance, but actual result is known after the happening of the event. Happening of the event is said to be, and this one is said to be random experiment. And this one is said to be random experiment. A repeatable experiment, the result we know in advance. Okay, before tossing the coin, we know that may be head or that may be tail. Coin weight and kanna munde manaku telustundamma. Adi head or tail edo compulsory padutundi. But we don't know the actual rate. That will be now after the happening. After I spin the coin, later on that may be on side or that may be on my hand. At that time we can say after removing the off hand, that is head and that is tail. And that one is said to be random experiment. Okay. Example is tossing a coin. Tossing a coin or spinning a die. Any one of these two. Tossing a coin or spinning a die, like that. And next one is trial and outcomes. What is trial? And second definition is trial and outcomes. What is trial? What is trial? Conducting or performing the experiment. This type of conducting. I am conducting tossing a coin. I am conducting this game. I am conducting throwing a die. And these type of events are said to be trial. Conducting or performing any one of these two. Conducting or performing the experiment. The experiment is said to be trial. Conducting or performing the experiment is said to be trial. And the possible results means that may be head, that may be tail, and that are said to be outcomes. The possible results are said to be, and this one is said to be what, Nana? Outcomes. The possible results are said to be outcomes. Same example, tossing a coin, and this one is example of trial. Or throwing a die, whatever it means, that is example of trial. And outcomes, here the outcomes is what, Nana? Outcomes. What are the outcomes? When you throw a coin, we get that is said to be outcomes. Okay, write down one. Tossing a coin is said to be trial, and head, comma, tail, these type of outcomes, these type of reals are said to be outcomes. And sample space. Next one is sample point and sample space. Sample point and sample space. What are sample points? What are sample points? In a random experiment, the outcomes are said to be sample points. For example, here head, comma, tail, and these one are said to be sample points. The set of all sample points are said to be sample space. For example, the outcome, simply I am writing now, the outcomes in a random experiment. In a random experiment are said to be sample points. Sample points and set of all sample points. Set of all sample points are said to be, are called simply, are called sample space. Are called sample space. Here we take another example. Let's throw a die. Let's throw a die. When a die is thrown, what are the outcomes, Nana? When a die is thrown, what are the outcomes? Throwing a die. What are the outcomes? 1, 2, 3, 4, 5, 6. All these are said to be outcomes. Die has 6 faces. 1, 2, 3, 4, 5, 6. You remember these things? They may change the face of die also. Generally, one